Welcome to this tutorial on building a multi-agent transcription system using AutoGen and AgentOps. Today, we will explore how to leverage these powerful tools to create an AI-driven transcription comparison system. Our system will use two AI agents for transcription, one using AssemblyAI and another using WhisperAPI. We will then use a third AI agent to compare and analyze the results. Finally, we will use AgentOps to monitor and optimize our agent's performance. By the end of this tutorial, you will understand how to build this system and gain insights into the capabilities of different transcription services. Let's dive in and start building our multi-agent transcription system with AutoGen. Hello everyone and welcome back to my channel. Today we are diving into Microsoft AutoGen, an exciting new open source framework that is transforming how we build large language model applications. Imagine creating an AI system with multiple AI agents that can work together, chat with each other, and even interact with people and external tools, all to solve complex tasks. That's exactly what AutoGen enables us to do. Whether you are looking to build advanced chatbot or creating an AI assistant that can code or develop systems for complex decision-making, AutoGen provides us with flexible and powerful platform to make that happen. So let's jump in and see how AutoGen is simplifying the development of large language model applications across various domains and complexities. Alright everyone, before we get into the details of AutoGen, let's first understand why it is such a game changer. As large language models like GPT-4o have become more powerful, developers have been looking for ways to harness their capabilities for increasingly complex tasks. But how do you scale up from a single AI agent to a system with multiple agents that require different types of expertise or need interaction with the real world? That's where AutoGen comes in. It addresses this challenge by enabling multi-agent conversation. Instead of relying on a single AI agent to do everything, AutoGen allows us to create multiple agents, each with its own roles and responsibilities. Then these agents can communicate with each other, with a human, and with external tools to solve complex tasks. In simple terms, an AI agent is an entity that can receive messages or send messages and generate reply using large language model, human input, and external tools, or a mixture of them. In this tutorial, we will focus on creating multi-agent system for transcription comparison using AssemblyAI and WhisperAPI. And then we will touch on how to monitor our agent using AgentOps. Central to AutoGen are conversable agents. These are flexible entities that can hold conversation powered by either large language model, human inputs, or external tools. A key feature is their ability to maintain context. This allows them to understand complex multi-turn interactions. AutoGen offers pre-built agents like the assistant agent, which is powered by large language model, and the user proxy agent, which is a human or tool-backed. The real magic lies in creating your own custom agent, tailored to your own needs. Imagine an assistant agent that writes codes and a user proxy agent that tests it and provides feedbacks. This collaborative loop continues until the task is done. Now let's dive into a demo and see this in action. In the next part, we are going to install AutoGen and start building AI agents. Alright everyone, let's get started. To install AutoGen, we have to install by AutoGen. So we have to run the following command: pip install by AutoGen -quiet. Let's run the code. In case you have already by AutoGen installed, run the following command to upgrade it: pip install --upgrade by AutoGen
AutoGen dash create. Run the code cell. After that, we have to load the environment variables. So we have to say the following. Here we'll say import OS to access the file server, and then from .env import load and find. Then we'll say load. Here find env override is true. Okay, let's run the code cell. And the environment variables are loaded successfully. Okay, now let's start building our first conversable agent in AutoGen. This is where we will bring those theoretical concepts to life. But first thing first, we have to import the conversable agent class from the AutoGen library. This is the core building block for creating our agent. So here we'll say from AutoGen import conversable agent. After that, we are going to create an instance of this class. So we'll say agent is equal to conversable agent. And this is where we define the key properties of our agent. The first one is the name. We are going to call it a chatbot. Alright. And the next property is LLM underscore config. This is where we specify the large language model we want to power our agent. In our case here, we are going to use GPT-4 from OpenAI, and we are going to securely pull the API key from our environment variable. So here we'll say the following is equal to object and then config underscore list. For model, I'm going to use GPT-4 and API underscore key is os.environ.get open AI underscore API underscore key. The next property is the code execution configuration. We are going to set this property to false to explicitly tell AutoGen that we don't want this agent to execute any code. This is a good safety practice, especially when we are starting out. So here we'll say code underscore execution underscore config is equal to false, and it is the default value. The next two properties are function underscore map and human underscore input underscore mode. For function underscore map, I'm going also to set it to none. We don't want to call any function or tool. And the human underscore input underscore mode is equal to never. So we set the function underscore map to none and the human input mode to never, because we don't want our chatbot to be calling any external functions or tools or asking for human input from a human user. We want the chatbot to depend only on the large language model for its response. Okay, let's run the code cell now. Okay, now let us send message to our chatbot and generate a reply. So here we'll say reply is equal to agent dot generate underscore reply, and for messages we are going to send the following: content, what is the capital of UAE, and for all is going to be user. Okay, after that we are going to print the reply. Let's run the code cell. And we get the answer. The capital of the United Arab Emirates is Abu Dhabi. This is a very basic example, but it shows the fundamental structure of how to create and use a conversable agent in AutoGen. In the next steps, we will explore more advanced features and build more complex agents.
Now that we know about conversable agents, let's explore how they collaborate. This is where conversation programming comes in. Conversation programming is AutoGen's way of orchestrating agent interactions. It's a two-step process. First, we have to define our agent, and then we have to program their interactions. AutoGen simplifies this by unified conversation interfaces and auto-reply mechanisms that allow agents to respond naturally. The key power lies in its flexibility. We can program conversation using natural language, code, or both. This allows us to create anything, from simple rule-based interactions to complex adaptive conversations.
Well, alright, now that we have understand how conversable agents work, let's see how they interact in a conversation. On AutoGen, we can assign roles to agents and let them chat with each other, just like in real-life conversation. And a conversation is a sequence of messages exchanged between agents. We can make this conversation to make progress on a task. Let's see how. First, we create two agents, a chef and a nutritionist. Each has a clear role defined in their system message. The chef is an expert in Italian cuisine, while the nutritionist provides dietary advice. We are using GPT-4 for both agents, and we have set the human input mode to never. This means that the agents will chat autonomously without needing any human intervention. Now comes the fun part. We use the initiate chat method to start a conversation between our chef and nutritionist. We ask the chef for a healthy Italian pasta dish and set max turns to 3 to keep the chat concise. Let's run the code and see what they come up with. I'm running the first code cell and I get second code cell as well. There you have it, a brief but informative chat between our AI chef and nutritionist, neatly wrapped up after 3 exchanges thanks to max_turns. Notice how they stay in character and provide relevant responses. Now let's talk about the human_input_ mode. This setting controls when and how a human can intervene in the conversation. Never, as we have seen, the agent chat autonomously. We have another option called terminate. The conversation stops if an agent needs human input. And the last option is always. A human is required to approve each agent response before it is sent. And their use cases are: never is ideal for automated tasks or simulation. Terminate, useful when you want a human oversight for critical decisions or sensitive information. Always is great for situations where you need full control over the conversation, like customer service or content moderation. Now let's introduce another way to control the flow of conversations in AutoGen, the max consecutive auto-reply parameter. We have added this parameter to our nutritionist agent and set it to 1. This means the nutritionist can only send one automatic reply before the conversation will terminate, even if there are further messages to process. Notice that we have removed the max_turns limit this time. The conversation will now continue until either the nutritionist reach its auto-reply limit or the chef decides to end it. Let's run the code now and see the conversation output. I'm running the first code cell and the second code cell as well. And there we go. The conversation paused after the nutritionist's first response. This is because we set the max consecutive auto-reply to 1. Now, and with the human input set to never, the conversation terminates at this point. If you wanted the conversation to explicitly request a human input after reaching the auto-reply limit, we could need to change the human input mode to terminate. Now let's explore another way to control the flow of a conversation in AutoGen. This time we will use the Termination Msg parameter. We have added this parameter to our nutritionist agent. It takes a function that checks if a message signals the end of the conversation. In our case, we have defined a simple function that checks if the message content contains the phrase goodbye. In our initiate chat call, we have specifically instructing the chef to include goodbye in their message. This will trigger the termination condition we have set for the nutritionist. Let's run the code now and see what happened. I'm running the code. And there it is. The conversation ended gracefully after the nutritionist reply included goodbye. This demonstrates how its termination message allows us to define custom conditions for ending a conversation, adding another layer of control and flexibility to our AutoGen interaction. A key point here is that The termination message function on an agent, it checks the incoming message it receives, not the one it's about to send. This allows for flexible control over conversation flow regardless of which agent initiates the chat. In this part, we are going to build a multi-agent system to compare the transcription accuracy of two popular APIs, WhisperAPI and AssemblyAI. We will not dive deep into the inner workings of those APIs themselves, but instead, we will focus on how to orchestrate them using AutoGen powerful conversable agents. Let's start with our first agent, the Whisper agent. Its job is simple: transcribe audio using the OpenAI Whisper API. This Python function handles the actual transcription. It takes an audio file, sends it to the Whisper API, and returns the transcribed text. Now, to integrate this into AutoGen, we have to create two agents. The first one is Whisper Agent. This is our smart agent powered by GPT-4. It understands natural language and knows how to use the Whisper transcribe tool. And the second agent is called Whisper User Proxy. This is a special type of agent called a user proxy. It acts as a bridge between our code and the Whisper agent. It doesn't have its own language model. Its job is to execute the actual Whisper transcribe function when instructed. Here's where the magic happens. We can register for LLM and tell the Whisper agent about the Whisper transcribe tool. This means the agent can suggest using this tool when it is relevant to the conversation. Then we use the register function for execution to tell the Whisper user proxy that it's responsible for actually running the Whisper transcribe function. Finally, we initiate a chat between the Whisper user proxy and the Whisper agent. The user proxy sends a message asking the agent to transcribe a specific audio file. The Whisper agent recognizes the task, will suggest using the Whisper transcribe tool, and then the Whisper user proxy will execute it and return the transcription result. Now let's run the code cells and make sure that the transcribe function is working correctly. I'm using a sample audio file from one of my videos. I'm running the code cell. First, we are testing the function, and we get the transcription. Then we will run the code cell for creating the Whisper agent and Whisper user proxy. It works. Now let's test our agent. And it terminates and we get the transcription. Let's now talk about the AssemblyAI agent. Now we have our AssemblyAI agent. Similar to the Whisper agent, its primary purpose is to transcribe audio, but this time it leverages the AssemblyAI API. The AssemblyAI transcribe function handles the core transcription logic. It sets up the AssemblyAI API key, takes an audio URL as input, sends it to the API for transcription, and returns the transcribed text. It also includes a check for potential error during the transcription process. Just like the Whisper agent, we create two agents for AssemblyAI. The first one is the AssemblyAI agent. This is our intelligent agent powered by GPT-4. It understands natural language and knows when to use the AssemblyAI transcribe tool. And the second one is the AssemblyAI user proxy. This is another user proxy agent responsible for executing the assembly transcribe function when instructed. Now here's where things get slightly different compared to the Whisper agent. We still use register for LLM and register for execution to connect the tool to the respective agent, but we also introduce a register function call. This is a more convenient way to register the same tool with both for assistant and user proxy agents in one go. It simplifies the code and makes it more readable. Finally, we initiate a chat just like before. The user proxy sends a message requesting transcription using AssemblyAI, and the AssemblyAI agent will trigger the tool call to get the job done. Let's run the code cells. First, the AssemblyAI tool, and then we are going to test this tool. Perfect, we get the transcription. Next, let's run the agent definition code cell and the register function call. Let me just scroll up. We get a warning, but we can ignore it for now. And finally, let's test our agent. I'm going to run this code cell, so I'm going to scroll up a little bit. I'm running the code cell now. And amazing, we get the results. In the next part, we are going to create the comparison agent to compare both transcription from the Whisper agent and the AssemblyAI agent. Finally, let's meet our judge for today, the comparison agent. But before we move on to the comparison, we need a way to extract the actual transcripts from the chat results returned by our Whisper and AssemblyAI agents. That's what this extract transcript function does. Here's the breakdown. First, it loops through the chat history in reverse order, starting from the last message. Then, it looks for a message from the user role that contains the word terminate. This is the signal that the transcription is complete. Then, it splits the message content using double quotes and grabs the second element at index 1, which should be the transcribed text. And finally, if it finds a transcript, it returns it. Otherwise, it returns none. This function helps us neatly extract the relevant transcription so we can feed them into our comparison agent. Now, the comparison agent is powered by GPT-4, and its task is to carefully analyze the two transcriptions we just generated. We gave it a very clear system message outlining its role and the specific metrics it should use for comparison, which are accuracy, completeness, correct spelling, and the overall quality. We have also told it to provide its analysis in a structured JSON format, which will make it easy for us to process and display the results. Now, along our smart comparison agent, we have the comparison user proxy. Remember, user proxy agents don't have their own language model. They simply act as a bridge to execute actions or interact with our agents. Here's how we have configured it. We have the human input mode, which is equal to never. This ensures the agent won't ask for any human input. And then the max consecutive auto reply is equal to 10. While not strictly necessary here, it's a safety measure to limit how many times the agent can reply automatically. Its termination message is set to lambda function. This function always returns true, meaning the conversation with the comparison agent will end immediately after its first response. We only need its analysis, not a back and forth chat. And finally, the code execution configuration is set up in the case the comparison agent ever needs to execute code. Though in this scenario it won't, but in a future video I'm going to show you how to create an agent for code execution. Now that we have our two transcription and our comparison agent ready, let's bring them together. This compare transcript function is where we orchestrate the final comparison. First, we build our comparison prompt. It clearly lays out the task for comparison agent. It asks to compare the two transcriptions. It reminds the agent of the evaluation criteria. It provides both transcription for reference, and crucially, it reiterates that the analysis should be in the specific JSON format we defined earlier. Next, we use our comparison user proxy agent to initiate a chat with the comparison agent, passing it the carefully crafted prompt. After the chat, we grab the last message from the comparison user proxy, which should contain the comparison agent JSON response. We then try to parse this response into a Python dictionary using JSON.loads. If there's any issue parsing the JSON, we print an error message and return none. Finally, we call this compare transcript function with our two transcription. If the comparison is successful and we get a valid JSON result, we print out the score, the winning transcription, the overall analysis, and any details error the comparison agent identified. Now let's run all the code cell of the comparison agent and make sure it's working fine so that we test it. We'll start with the extract function, then the Whisper transcript. We get the Whisper transcript, and then the assembly transcript. We get also the assembly transcript. Now let's run the code cell for the comparison agent. And then let's run the code cell also for compare transcript. Now we are going to test our agent. All right, I'm gonna scroll up a little bit so that we see the result. I'm running the code cell now. And here's the verdict. As you can see, the comparison agent have given Whisper a higher score, highlighting its superior accuracy in spelling and handling of proper nouns and idiomatic expressions. It also pinpoints specific errors in the AssemblyAI transcription. This demonstrates the power of combining multiple AI agents to perform a complex task. We were able to get two different transcriptions and then have a third agent intelligently analyze and compare them for us. This type of workflow can be incredibly valuable for tasks like quality control, data validation, or even automated decision making. We have built this awesome multi-agent system, but how do we know if it's working as expected? That's where AgentOps steps in. AgentOps is a powerful platform that provides observability and analytics for your AI agents. It helps you track key metrics, identify issues, and gain valuable insights into how your agents are interacting and making decisions. Now let's see how AgentOps help us monitor and understand what's happening behind the scenes in our multi-agent system. It's as simple as adding a few lines of code. We initialize AgentOps with our API key and start a session. Now, every interaction between our agents is automatically tracked and logged. Look at this dashboard. AgentOps provide us with valuable insight at a glance. We can see things like session end states, how many sessions were successfully or failed, session duration, how long conversation typically lasts, event errors, if any errors occur during the interaction, and much more. This helps us understand how our agents are performing, identifying potential issues, and improve the overall user experience. AgentOps makes it easy to gain visibility into your AI agents, turning complex data into actionable insights. It's a powerful tool for anyone building with AutoGen. Please remember, this is just a taste of what's possible. AgentOps and AutoGen offer a whole world of possibilities for building complex, intelligent AI applications. If you are hungry for more details or have specific questions about any part of this tutorial, please leave them in the comments below. I'm always happy to help. And stay tuned because this is just the beginning. I will be releasing more hands-on tutorials in the future, diving deeper into specific use cases and advanced features.
And there you have it. We have just scratched the surface of what's possible with Microsoft AutoGen. We have seen how it allows to create customizable AI agents, program conversation, and integrate various capabilities including large language models, human inputs, and external tools. Remember, AutoGen is incredibly flexible. It allows to create everything from simple chatbot to complex multi-agent system for tasks like coding, data analysis, and decision making. I encourage you to experiment with AutoGen. Try to create your own multi-agent conversation application and see what kind of innovation you come up with. The possibilities are endless. And finally, if you enjoyed this tutorial and want to learn more about AutoGen, be sure to hit the like button, subscribe to my channel, and ring the notification bell. Thank you for watching and see you in the next tutorial.